All right, so imagine an object that's been drifting for, well, maybe billions of years through that dark, cold space between stars. It's from a whole other solar system. Today, we're going to dive into a pretty incredible cosmic detective story all about a visitor named 3I/Atlas. And look, this isn't just some random rock floating around. This thing is a true outsider. Get this, it's only the third known object to ever visit us from interstellar space. It's like a messenger from a place we've literally never seen. And the thing is, it's not sticking around for long. And when I say it's not sticking around, I really mean it. This thing is just hurtling through our solar system at over 150,000 miles per hour. I mean, that's just an insane speed. And that speed, well, that's what tells us the first part of its story. Okay, so our first big clue in this cosmic investigation is the comet's path. Right away, you can see it's not moving like anything that actually belongs here. It's on a one-way trip, and that trajectory is like a flashing neon sign telling us it's an outsider. So to really get why its path is so weird, we need a quick rundown on a term called orbital eccentricity. Don't worry, it's pretty simple. It's just a number that describes the shape of an orbit. A 0? That's a perfect circle. But the higher the number goes, the more stretched out and open that path gets. And here you can see the key difference. See, pretty much everything in our solar system is locked in by the sun's gravity. It's all moving in these closed elliptical loops. But 3I/Atlas, nope, it's on what we call a hyperbolic path, which is basically an escape route. It's just passing through. So, what does that actually mean? You know, a path like that, powered by such an incredible speed, what's the big takeaway? Well, here's the crucial point. Our sun's gravity, it's just not strong enough to capture it. It can't pull it into a stable orbit. So this brief, super high-speed flyby, this is our one and only chance to study a real-life piece of another solar system before it just disappears back into the galaxy forever. All right, let's move on to our next clue, because this is where the mystery really starts to build. When astronomers pointed their big guns, instruments like the James Webb Space Telescope at this comet, they found a chemical recipe that was, well, it was unlike anything we've ever seen from one of our own comets. So as the comet got closer to the sun, things started to heat up, right? Its ice began to vaporize, creating this big cloud of gas and dust. And inside that cloud was this cocktail of chemicals, but it was dominated by huge amounts of methanol and hydrogen cyanide. Now, those are compounds we just don't typically see in such high levels in comets from around here. And this chart really just drives the point home. I mean, look at how different it is. You can see the concentration of these specific molecules. 3I/Atlas is just completely off the charts compared to a normal comet from our system. We're not talking about a small difference here. This is a fundamentally alien makeup. And here's why that is so fascinating. These aren't just any old random chemicals. They are the kinds of molecules that scientists get really excited about, the ones associated with the complex chemistry that can, eventually lead to the building blocks of life itself. So naturally, this has led to some pretty big questions. Does this just mean that the basic ingredients for life are, super common all across the galaxy? Or could it point to something more? There's a pretty wild theory that suggests objects just like this might act as cosmic seeds, literally transporting life's starter kit from one star system to the next. But hold on, because the mystery doesn't stop with its chemistry. Our third and final clue is maybe the strangest one of all, the comet's totally bizarre behavior as it flew by. Seriously, this is where things get really weird.
So people watching this thing noticed it wasn't just glowing steadily. Instead, it was brightening and dimming with this incredibly precise rhythmic pulse, almost like a heartbeat, going off every 16.16 hours, like clockwork. And that wasn't even all of it. It also showed other strange things, like a faint anti-tail. Now that's a stream of dust that seemed to be pointing towards the sun. That's completely backward. The solar wind should be pushing everything away from the sun. So yeah, you can bet these things have really puzzled astronomers. Now look, on one hand, there could be a perfectly natural explanation for all this. Maybe that heartbeat is just caused by a fast-spinning, weirdly shaped nucleus, kind of like a wobbling potato reflecting sunlight. But on the other hand, that pattern is just so regular, and the other stuff is so strange that it's really fueled a huge debate about what's actually going on. So after looking at all of the clues, the trajectory, the weird chemistry, the strange behavior,
what's the verdict? Well, the truth is, 3I/Atlas has left us with way more questions than answers. It's not really a smoking gun, it's more like a cosmic messenger. And what this messenger confirms for us is a really profound reality. We are not isolated in some cosmic bubble. Our solar system is part of a much larger galactic neighborhood, and we are constantly interacting, sharing material with other star systems light years away. And that's exactly why these visitors are so incredibly important. Each one is basically a time capsule. It's a perfectly preserved sample from another world, giving us this unbelievable peek into the chemistry and the conditions around stars we can only dream of ever reaching. So, as 3I Atlas fades away, back into that interstellar void, it leaves us with this final, massive question. What is this messenger trying to tell us about the galaxy we call home, and about the neighbors we haven't even met yet? And you have to wonder, could it be that those neighbors are sending us the very seeds of life itself?